In this video, I will talk about how to use software interrupts and how to use them to do input and output. A software interrupt is a signal to the processor indicating an event that needs immediate attention. I think the professor will talk about the details in the future class. Now, we can just consider a software interrupt in ARM-Sim as the entrance of a specific function. The user guide will give you some ideas about how to use the SWI in ARM-Sim. For example, if you want to display string on the console, you can just move the address of a string to R0 and then you call SWI02. And then, if you want to write a string to a file, you should move the file handle to R0 and the address of string to R1. Then you can call SWI69. You can find more detail in the user guide here. There are also some detailed description show you that how to do these software interrupts. I think it will be very useful. Now, let's look at the sample program here. It handles the standard input and output. The first few lines of this program are equal statements. You can consider the equals here as the defined statements in C language. With these statements, you don't need to remember the number of SWI. You can just call like SWI string, like what we are doing here. With these statements, you can make your program easier to understand. Also, here is a statement about the standard input and standard output. The standard input is equal to 0 and the standard output is equal to 1. You can consider the standard input as a file and its handler is always 0. Therefore, if we pass 0 to R0 and then we call SWI read string, we can get the standard input, same as the standard output. In this problem, we also have a buffer here. It will store the input after the SWI read from the console. And here, the match 1 has a string that we will use to ask for input. Okay, let's load the program in ARM-Sim. We can easily see, here are breakpoints. We need to remove this. Okay, we can see the memory if we choose to watch memory here. Because the buffer starts from 103C, let's locate it to 103C. Okay. So we can find the buffer has the two complement of -1, -1, -2, and -3 at the beginning. And if we change the word size to 8 bits, the bytes will be expressed as the characters. So there is string enter a number between 0 and 999, same as here. Then we run this program step by step. We pass the standard output handle to R0 and the address of string to R1, then we call write string. Then here is the message. Now we pass the standard input to R0 and the buffer address to R1, the bytes count to R2. Here R1 indicates where we would like to save the string, and R2 indicates how many bytes we would like to read from the input. Now we call read string, and the program is waiting for our input. Let's enter like 1, 2, 3. Okay. Now you can see here are 1, 2, 3 and a null terminating the string here. If you would like to output 1, 2, 3 again, we can just move the address of buffer to R1 here. Do the same thing as what we have done before. So here is 1, 2, 3. And then we go to the SWI exit. It is a better way for us to exit. I mean, it is more elegant than what we have done in the last program. You can see if we step into it, we can stop it or reload it. If we do like what we have done in the last program here, let's see, we run it and we cannot stop it. So I suggest that you can use SWI exit. Okay, that's it.